Okay. So, hello everyone, welcome back to another episode of the Codersarts. So, in this series of episode, we only talk about the project's demo, project showcasing, also the project code walkthrough, and even you will see how the complete projects flow work. Okay, and how what are the different technological aspect and what are the different coding challenges, and even you will get based on that how other different type of use cases can be possible. So we will try to cover all the concept like problem statement, what are the final output, what are the code walkthrough, what are the flow of the project, and what are the different challenges. So throughout these projects we will you will get this type of idea. So one of our team member Pranav, so he will explain what the project's about, what are the technology, and obviously what are the category this come under machine learning, deep learning, NLP. Also he will explain, and also you will get the complete code walkthrough of this project. Okay, so now I'm inviting Pranav, so he will explain everything about the project. Okay, so hi Pranav, now you can first brief about what the projects, then you can so the what will the final output, then we can start from presenting a screen, what will the code walkthrough, or even and other technical aspect of the project. Okay, so go ahead and just present
About
your
the
screen and
project.
explain.
Okay, so the basic problem statement we are trying to address in this particular project is that we are going to detect the movements of a person and classify those particular movements by using deep learning
Hmm.
algorithms. So this project is basically like we divide it into two parts. So in the first part, we are using a deep learning model to perform all the detect all the joints in a person.
Hmm.
So once that joint is detected, we are using that prediction and giving it to another deep learning model, which has learned to classify different joint
Hmm.
positions and classify them as particular actions being performed by a human. So that is the basic problem statement. So
Hmm.
why we choose this particular problem statement is that it is has like very good applications in all major manufacturing sectors, etc., where the through CCTV camera, etc., like we will be able to like detect the motion of the workers, and if for some safety reason if we have to see if worker is in a non-safe position, we can create an alert system based on top of that.
Okay, okay. So basically, yeah, it's a basically human movement traction, right? So, or
Yes.
maybe can human gesture recognition or something like that. Okay. So present a screen, and so how the final output will
Yes.
look like.
So this is how the final output will look like. So this is just a clip from a particular movie. So in that, as you can see, the person is waving the
Hmm.
hands. So what we are doing is that by using some data set, we have already trained two models for this particular set of problems statement.
Hmm.
Then we have given it that model the input, and we are taking the output. As you can see, the label of that particular action is being printed over here.
Hmm. Okay, okay, fine. Now you can start from the beginning how you implemented this code, and also first explain what this. I think you have already explained this come under deep learning, right? Or any other category?
Yes, sir.
Okay. Fine. So start from the go with the beginning and explain how this project or code you are implemented.
So there is one popular data set called as Flick data set.
Hmm.
So in that Flick data set, what they have done is that they have collected images from many
Hmm.
movies, and what they've done is that they have identified many features from that movie and created a data set.
Hmm.
So out of that data set, we are just using the key points out of that.
Hmm.
So here I've just shown a like sample image. So in this sample image, what I've done is that they have marked both the elbow positions, wrist and shoulder, and along with the head position of all the characters in a particular frame.
Hmm.
So by doing that, they have like created a data set where if we give a model, the model should be able to like detect all the joints of that particular human given in that particular frame.
Hmm.
So this is the data set that they have used. So for training this particular data set, what you have to majorly import is that the deep learning framework which we are using is TensorFlow.
Hmm.
and then we are using NumPy to handle some data related augmentation part of that data set. Then we are using the matplotlib to plot those particular images.
Mm-hmm.
So these are just codes to set up the GPU in that particular environment.
Mm-hmm.
So after that, what we are doing is that we are importing that particular data set. So that data set is given to us in the form of a CSV file,
Mm-hmm.
where each image name is given along with all the key points that are detected in that image. So we are just reading that particular CSV file and doing some conversion so that we can directly plot some sample results. So I am just using the matplotlib library to plot some sample images to see what our dataset actually looks like and should we do any modification or not.
Mm-hmm.
So once we go through this, understand that particular data, then we are starting to convert it into uh, um, in a TensorFlow dataset format.
Mm-hmm.
So why we are doing is that is the number of images, though it is good, uh, we need to augment this dataset so that we can better train the model. So in order to do augmentation, we need to find the original shape and size of this particular images. So that is what we are trying to find here. We are finding what is the shape and size of this image. So it is 224 comma 224. Then after that, we are just doing the data preparation step for converting it before giving it to that particular deep learning model.
Mm-hmm.
So after that, we are using a uh, function from TensorFlow called as tf.data.dataset, and from that, if you give the list of images in a path, we can directly convert it into the dataset format, which is as recommended by TensorFlow is the most optimal format for training TensorFlow models.
Mm-hmm.
So once we convert it into dataset format, we are defining a function to read those particular images from the path files which we are given. So we have just defined an function called as load image to read those particular files. Then after that, we are just converting all the images in that dataset into image format using the function here. So this is just it's to see that if all the image path files given to the dataset has been converted to that particular image.
Mm-hmm.
Then after that, we are next adding all the key points to the dataset format. So again, the same list format is given to dataset. We are converting it into the dataset TensorFlow dataset format. Then after that, we are making a final dataset called as train DS, which we will be using for training. So I have just created that over here.
Okay.
Then for testing dataset, like they have given a different data frame for testing related images. So we are just doing the same process as we have did for training for the testing also, and we have created a final test DS for the testing purposes. So in the original training data file, we are having around 4,429 images, and in the testing, we are having around 574 images in that.
Okay.
Then these are some mm, uh, code to create batches of images before giving it to that particular deep learning model.
Mm-hmm.
So we are creating a batch size of 16, and this cache.prefetch option is nothing but uh, if a particular data set is already been given to a deep learning model, what this does is that it already preloads the next batch that needs to be given to the model. So it like saves us time during the training process.
Mm-hmm.
Then we are importing all the required like components for building this particular model, and for this model we are basically using VGG16, which is a pre-trained model,
Mm-hmm.
and we are adding many more layers on top of that to get uh, the final output which we require.
Okay.
So in that we are creating defining the model here and defining the weights to be ImageNet over here. Then we are setting all the layers within the VGG is weights to be constant, so we are not going to change the weights within the VGG. We are only changing the final few layers before the output layer of the VGG to be trainable, so that we can get the outputs accordingly in our required format. So once we get the output, we are just flattening that particular output, then giving it to a set of neural layers so that it can learn that and give us the output as 14 different key points, which we have given or which we have recorded it for each particular image.
Mhm.
So in this function, we are then we will just get the model defined. So once we get the model defined, we have to define a particular loss function for this model. So usually, like TensorFlow has some pre-built loss function which we can use, but for this particular key point detection, we have to like define a custom loss function called as coefficient of determination.
Mhm.
So we are just defining that particular loss function over here. Then after that, we have defined the optimizer for the model. Then we have compiled the model. So as you can see, this is the model which we have just built over here. So it contains around 21 million parameters, and out of which we are training only 13 million parameters, and the base VGG model part around 7 million parameters. The weights will remain the same. So once we train this particular model, as you can see, so we run it for a lot of epochs to get the best possible result, because the model like learns over mostly around 60 to 70 epochs.
Mhm.
So once we run around 94 epochs, we are getting final validation coefficient of 0.94. So the closer it is to 1, the better the model performs. So it is close to say 94% accurately. It is able to predict the key points of that given image.
Mhm.
So we are just plotting the training loss to see if uh, it is going according to what we have planned, and we are also plotting the R2 to see how it has performed over certain number of epochs.
Mhm.
So after that, we are just saving this particular model
Mhm.
into a .h file so that we can use it later. So in the next process, what we are doing is that creating a new model for detecting the action based on the given key points. So in that, we are again using the same set of libraries: TensorFlow, NumPy, Matplotlib, and Pandas for reading the data frame.
Mhm.
So here we are using a new data frame called as action joins, which, as you can see here, will have 14 key points and the label of that particular positions of key points. So as you can see,
Mhm.
these set of key points indicate that action to be hello. So like that, we have given many images of different, not of the same person, of different persons, so that it can learn to differentiate between all the persons and just focus on the key points which we have given to that particular model.
Mhm.
So another action here in this particular data. So in this data set, there are only mainly two action which we are focusing on just for showcasing purpose.
Mhm.
So one action is hello, the another action is label.
Mhm.
So we are just processing that set of inputs into again the same format as before. So these are the code for that.
Mhm.
Then we are creating two data sets. One is train data set and another one is the test data set, and again we are converting into tf data set format
Mhm.
for giving it to the ml model.
Mhm.
So we are just building a simple classification model. So it takes in a set 14 inputs, then gives us the output that whether it is the action can be classified as hello or namaste.
Mhm.
So we have just defined that particular model over here. Then this model has around 337,000 parameters in that model. Then we are defined again, use the optimizer to be Adam, and the loss to be categorical cross entropy loss, which is the standard loss which we use for classification purpose. And the metrics which we are going to measure in this case was accuracy. So after that, we are training for around 100 epochs. So after certain epochs, as you can see, the validation accuracy goes to around 100%.
mm,
So once the validation loss stabilizes, we just stop the epoch over there around say 76 epochs.
mm,
Then we save this particular model. So for saving the code was included during the training itself,
mm,
known as model checkpoint.
mm,
So it saves the best model as final action model.h5 format.
mm,
So then after that, we are defining two functions. So in the first function, we are just reading that particular image file. So the image file which we are giving it as input is called waving.mp4. So it is just the action hello which is being performed here. So we are defining the function to like read those particular video file and generate each frame as images.
mm,
So next function, we are converting uh, frames to video file.
mm,
So after getting all the individual frames from the previous function, we give it to both the models.
mm,
So in the first model, we are getting all the key points detected, and in the second model, we are getting the action to be detected.
mm,
So once we get the particular action, we are like using the class map. So 0 means hello and 1 means namaste.
mm,
So if the action model say it is 0, then we are going to say it is hello, and if the action model say 1, we are going to say it is namaste. Then after getting the result, what we are doing is that we are using OpenCV to create a new sample GIF file for that, or a video file. So we are reading those individual frames individually, and uh, we are like uh, giving a text to that, adding a text to that particular frame indicating the action being performed in that particular frame. So in the video, as you saw in the initial stages, so throughout the video we get the heading to be, or the action to be hello. So that is how we are going to do here. So once we append that particular text to that each frame, we just create a final video or numpy array as output, and we are using that output to convert it into a GIF format, and we get the output to be this video.
mm.
So that is how we have designed the whole project.
So any other action can we detect? So only one testing image is there.
Hello and namaste, sir.
So in this case, only hello is there. So is there any others?
So we have no, I have not have the video for that particular namaste action to be detected.
Okay, so again we have to check or test other videos. So then again we have to process, follow the same process, right? Or maybe
Yes, sir. We just have to give the new video as input to this particular set of
oh.
pipeline which we have
Mhm.
prepared.
Okay. Okay. So obviously, this I think this is a. I don't think this is a small project, but because it's a three different file you have created. Okay. So first,
Yes.
what is use of all these different file and what are the follow? Like just give me as a a top level view, like how we'll follow this step. Like what are the use of first file, second file, third file, and how will go the project.
So the three files just have created is for like differentiating all the codes into separate files so that it is like easier to manage.
Mm,
You can like do the all the codes in a single file also.
mm,
We just did for the sake of like understanding what different codes mean to that particular
mm,
set of problem statement. We have just separated it into three files.
mm,
So as I said, in the problem statement itself, we have defined or separated that problem statement into two parts.
mm.
So first is key point detection, and the next is detecting the action. So we have just created two files for separately, so that the code can be differentiated is much more easily in that.
Hmm. So in first part, like in first part, you are training with images, right? So that is
Yes.
static images, right? And second one, your
Yes, sir.
second one is using video, right, for detecting the action, or is the again images?
No, second one is also static images.
Hmm. So how this basically working, like, so with the help of key points, like, so again, in actions, or key point, you are extracting from or getting the information from both this code, right? And in last video we're
Yes,
talking
sir.
about, again from video we capturing some images, and based on that images we are training, right? And we are taking some frames, image frame from the video, and then we are
Yes.
matching, right? but
Yes,
but
sir.
all the things will be done using the images, obviously. At the video is also a type of multiple many
Yes.
images scrolling or moving, okay. Okay, fine. So what are the learning of this project? So someone want to build this project. So what they will
Yes.
basically learn? Also explain, not coding level. So like first you can explain, like, uploading the video, creating uploading the video is one key point. Also, converting these video image frames. Again, you are taking this video and converting images to a video itself, adding some text. Okay, so it's described like that. Like what will the learning
Okay.
overview? So how somebody will learn?
So the first learning is that we will learn how to like handle images as input. So in traditionally, what getting into deep learning we learn is that how to classify images.
Hmm.
But once we are done that, we just go on to other regression related tasks, which does not handle images. So in this particular project, what we'll try to learn is that we try to identify each particular point in an image, and we uh, can learn how to develop models to identify those particular points and mark those particular
Hmm.
points. So as I shown in the dataset, so we can learn how to identify such key points in an image, and we can also learn how to like develop models to identify those key points in that particular image.
Okay.
Other than just classifying the whole image, we can try. We'll get the learning how to develop models so that we can identify individual parts within an image
Hmm.
in the first project.
Hmm.
And in the second project, it is a very simple like usual learning path for ML related courses or engineers to design a simple regression or a classification task where we give numbers as input and get the output in the either in the form of a regression or as a classification form. And in the third file, we learn how to handle video related inputs and how we can generate our own video using set of frames so that we can like expand the model into the video format also.
Hmm. Okay, so what were the common challenging part that their people will face? Because sometimes people are not able to execute the code completely, right? So that is one
Yes.
challenges. So what are the things you recommending or you face actually? What are the challenges you face during the project?
Yes, sir. The main challenge in this project is to design a model for key point detection.
Hmm.
So unlike the classification models, which relatively like is easier to design, the key point detection models we need more amount of fine tuning, optimization, etc., and
Hmm.
many number of iteration
Hmm.
of model we have to build before we can finalize a single model. So while designing this project, we will like learn a lot more stuff about how we can modify this model slightly so as to improve the result slightly, and how we can include a particular layer or not include a layer, etc. So basic how optimization and fine tuning of models can be done to achieve better performance.
Okay, okay. So is there extra hardware required for running this project, or maybe normal computer has GPU, normal GPU will execute this code?
Normal computer should be able to execute this.
Okay, okay. So Pranav, somebody want to learn this project from scratch. They want to build, not from scratch. What,
Yes.
how you have implemented. So basically, they somebody want to learn some. They either need some one and projects sessions, like projects training, something like that. So generally, how much time somebody can learn? If they have some basic understanding of machine learning and they want to complete this project, want to learning how to build this project. They want to complete learning, right? So how much generally time required
So
for
it will take around
learning somebody?
4 to 5 days to like completely learn this project. because most of the time goes into the optimization of the models, which is slightly time consuming, because we have to train the model, then test, and if the model is not performing again, we have to do the training process again. So this project, to learn this project, it will take us around 4 to 5 days for ML engineers who are just coming into this particular ML field to learn this particular project.
Okay, okay. So somebody want to learn one by one as a project-based learning or live project training, so they can also either they already have been lots of information available so on internet. So this is a common problem. So they can learn from their own, and if they stuck somewhere, they can get help from us, from our developers or machine learning engineers. But if they somebody have there is no any experience, they don't know even how to execute the project, because sometimes if you are using internet for even the for a small machine learning task, you will easily get the complete code. But sometimes if the project is larger, so even if you get some online code, if copy paste directly, they are not working. So there might be compatibility issue, library issue. So obviously once the project is little bit getting more complex or intermediate level, even advanced level, so very few tutorial you will get, or any tutorial blog you will get there, the complete code will find, and that code will execute it. Okay, so that is one very challenging part. Okay, so based on this, after completing this project, so what are the other different type of tasks somebody can perform or can work on this, like if this project are completed, right? So based on that, what are the other use cases of this project?
So, as I said, so once we learn how to develop this project, we can also go for object detection models.
Hmm.
So, detect each individual objects in a particular image. So that is like very important knowledge to have for an ML engineer, especially in an industry like scenario where like we have to identify what object, like multiple objects within a single image instead of just classifying the whole image. So we may have to like localize those object in that image, and also say what that particular image or object is. So by do like trying to learn this model, or building this model, we can, ML engineer can learn how we can build object detection models.
Okay, so I got one point, like in this frame, main idea was finding the exact keyframe. Based on the keyframe, we are detecting the action, right? Though finding the
Yes,
keyframes
sir.
or keyframe or key point. So similarly, if we this concept are using, so maybe so like you had already talked about, the same project can be integrated. Some manufacturer and some industry there, we need to track the worker. Also
Yes,
there
sir.
is some drowsiness detections in somebody is driving the car, so it will use the same concept or other concept. There might be something drowsiness of the car, uh, drive
Uh,
drowsiness of the driver, I
no,
think.
sir. That is also very like similar to this.
Hmm.
Not as complex, because we just have to detect face of that particular
Hmm.
person over in
Hmm.
that case.
Okay, so again in that case also we have to find keyframe or key point or something else.
Yes, sir. Because we have to like localize where that face is within that image,
Hmm.
for us to say if the person is
Hmm.
drowsy or not.
Okay, okay, because we are not recognizing or detecting the whole body, because only we have to detect
Yes,
the
sir.
face. Based on that, we have to find the keyframe of eyes, eyes sleeping or not,
Yes, sir.
something like that. Okay, so one is movement. We can track the movement of the persons, or maybe in a even the object can be like animal tracking or something like that can be done with the same.
Yes, sir. Yes, sir.
Okay, okay. So I think the common question or common concept we can say here is finding the right keyword, keyframes, the key points, and based on these keyframes, localize like what are the things we have to find it out from the images, and then so there might be numerous use cases for this one, like uh, on movement detections or um, finding the worker movement, recognizing even the secure surveillance system also we can use, find the person or
Yes, sir.
anybody is coming in some avoided or somebody area, or maybe other things androgynous. Okay, so there might be anything. Okay, fine. And so basically, if this type of project we are working, so what will generally be used, like TensorFlow, Keras, or any other things, or maybe even we can build from a scratch. So what are the about the technology? So most of the things will be solved by TensorFlow or from?
Yes, sir. So for a beginner, I recommend using TensorFlow for this particular project.
Mhm.
But if the person like the recent TensorFlow like does not support GPU directly in Windows
Mhm.
now. Previously, it used to support. So after later set of update, it is not supporting, and it only supports GPU in Linux systems.
Mhm.
So if a person is using Windows and
Mhm.
want to use GPU, then I would recommend using PyTorch instead of TensorFlow.
Okay, 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 fine. So I think that's all for everything about this video or this project, or anything else we have missed or you want to share, or all that covered.
No, sir. I have completed all aspects.
Okay. Okay, fine. So let's close this as a final note. Okay. So that's all, everyone. I think you got some idea from this project. Might be even, what are how the flow of this project, what are the technical aspect, and how actually these are different technical points. Technical points about the technical flow, like how we have to, for load the images, when we have to convert these images in the video, when loading this video to the images, and how to find the different keyframes, and especially what are the top level overview. I think from you will not able to get the complete code, because we have just only explained the code walkthrough. Maybe if you are implementing from your side, it might face many issues, but I think there might be many different type of learning as well. So we are recommending, please watch this video as well, and if you are getting some idea, like at least you will get this idea, like how these projects are working, what are the technologies used in this type of project. And also this type of project is also you are apply as a machine learning engineer, or maybe data scientist, or maybe as a want to specialize in deep learning engineer. So this type of project is very helpful, are also going to add value to a resume, right? And this is not very basic level project, but still they have many learning on this type of project. So even you have want to live training from us, like to learn how this complete project, so also you can contact us. We will assist in even the code level projects, mentorship or project assistance. And even if you are enroll in some courses like this, and even you are not able to complete these courses and you need assistance from any code level, so we can also help there. And even if you are a startup company, or maybe any of the company and want to launch this project's idea as a your MVP, or maybe even your developer want to work as a proof of concept, then you can also contact. We offering like complete full-fledged solution, even you are a student, learner, developer, or even you are large enterprises. So our developers, our team will help to complete and your task done at time, and what even based on your demand, what you are looking in this project. Even we can make some customizations, and even we can implement some algorithm from scratch you are needed. So there is many solutions we are offering, so you can visit our website. Even you can explore our videos as well, and you will get more idea as well. Okay, so that's all, everyone. Let's meet in another one. Till then, keep learning, keep growing. Thank you for watching.